Good evening, good friends, and I feel a bit bored, so I decided to just do a problem of calculus, and then let's check what we can do with that problem on the board and just enjoy ourselves. So the question says we need to evaluate this question, this particular problem on the board. Before evaluation of this problem, I want to show you something. Um, there are things called SARS in mathematics. I don't know, what does your teacher say? SARS? Sounds a bit absurd, but it's fine. Um, so it's SATs. So we need to, let me show you something. In SATs, when you are given 1 all over root 2, they say to you, basically, I would say rationalization of the denominator, basically, yes. So you need to rationalize this denominator by basically doing what? Multiplying by root 2 all over root 2. Root 2 1 multiplied by root 2 is going to be root 2 all over root 2 multiplied by root 2 is going to give us a 2. We have rationalized the denominator. Now, I want to show you another thing. 1 all over root 2 plus 2. We need to write it maybe in a rationalization way. We need to make sure that we get rid of this particular thing. So we're going to write by rational. We change the sign here. It's going to be root 2 minus 2 all over root 2 minus 2. If you can check, root 2 over 2 is 1. Root 2 minus 2, root 2 minus 2 is basically also 1. So how are we going to go about it? This multiplied by that, it remains as it is, root 2 minus 2. Then here, we'll be having something like this, root 2 plus 2, root 2 minus 2. And therefore, we still have root 2 minus 2 in the numerator here. Root 2 multiplied by, what's that? Root 2 is going to give us a 2. And then as you can check, we'll be having this multiplied by that is going to be minus 2 root 2. This by that is a plus 2 root 2. And this by that is going to give us a minus 2. This was not a conventional problem, but it's not a train smash. I just wanted to show you something. This will cancel that. And then on top, you're going to have root 2 minus 2 all over 2 minus 2, which is 0, which is basically, I think, is undefined. But the whole problem that I wanted you to see, the whole idea of showing you this question is this. I'm going to apply this knowledge here. I'm going to apply the very same knowledge here. And I think I should do another problem just to show you whereby we are not just going to rationalize the denominator. We will be using to rationalize the numerator. So now let's enjoy our time. So let's check what can we do here. So let me rewrite this question and say 1 all over root x minus 1 minus x plus 1, and then write my dx here. Or even if I don't write it there, just to get straight to the point, you see the sign here. Right? We will continue writing our integral sign. I'm going to multiply by x minus 1 plus root of x plus 1 all over. I don't know if maybe I'm losing my markers, but it's not a train smash. We'll find something else. We will be writing x minus 1 plus x plus 1. And then we multiply the numerator. I think I'm going to erase many times, but it's not a train smash. I'll just try to squeeze it in that particular position. Or maybe I should write simply. Just write 1 here and then my dx there. And then here on top I'll be having root x minus 1 plus root of x plus 1. I hope you'll be able to see. Let me use red. In the denominator here, I'm going to have two fractions, or rather brackets. These two, it should remind you of, if I say root 2 multiplied by root 2 is going to give me what? A 2, because the roots are going to cancel each other. So here, the inside part of the fraction of the square root are the same. So the square roots are going to basically cancel each other out. And therefore, I can therefore put it inside the bracket to have x minus 1 for these two. And if you can check, if you remember well, when we have this 2 root 2 minus 2 and then root 2 plus 2, we ended up having a 2 and then a plus 2 root 2 and minus 2 root 2 and then, sorry, that was not 2, that was 4, then a minus 4. And then these two gonna cancel each other out and they will have 2 minus 4, which is gonna give us negative 2. So I want to do what? I want to avoid writing these two because either way they are going to cancel each other out. Because of space, I am not gonna write these two because if you can check, if I say root of x minus 1 multiplied by root of x plus 1 and the same, they are going to cancel each other out. I'm going exactly straight to having root of x plus 1, which is negative, multiplied by the positive 1 here, such that I can say negative and positive is going to give me negative, and then put it inside the bracket to have x plus 1, such that I can distribute the negative sign. And then if it will help me, it will continue writing. I'll be having on top is going to be root of x minus 1 plus root of x plus 1. In the denominator, I have my x here, minus 1. This multiplied by that is going to give me my negative x. This and that is going to give me negative 1. And then the x's are going to cancel each other out. Let me erase this part, or maybe write here inside this particular box. I'm begging for space now. So this is gonna be like in the numerator I'm forgetting to write my dx. Mathematics people are going to shout at me, but it's fine. I have my root x minus 1 plus root of x plus 1, and then I have negative 1, and negative 1 is going to give me negative 2 dx. Fine. So now another thing, I can divide this by 2 plus this and that. However, negative and positive is going to give me negative. Therefore, I can continue to say I have root of x minus 1 all over minus 2. And then negative and positive division is going to give me that. And then I'll have x plus 1 all over 2. And then the dx part. Now I can separate the two integrals. Now I'm in these two fractions and write it as two separate integrals. Let me just erase here. This is a beautiful problem. I love this problem. We'll end up writing it this way. Integral of, let's remember something. The square root of x can be written as x to the power of 1 over 2. Therefore, if it is the square root of x minus 1, can also be written as x minus 1 all to the power of 1 over 2. So I can change this and have negative and positive, so it's going to be negative. What can I write? X minus 1 to the power of 1 over 2 all over 2 dx minus, because the sign is minus, integral of x plus 1 all to the power of 1 over 2 all over 2. Now, we come back here on top. I'm going to use a rate for now. Therefore, I'm going to eliminate, or rather remove the halves and put them in front and have it like this. I'm going to remove it with the sign, negative 1 over 2 integral of x minus 1 all to the power of 1 over 2 dx. Similarly, 1 over 2, let me just create some space here on top. Oh, mathematics and space. Can just do it this way. I know it's going to be shortened as we go further. Negative 1 over 2 integral of x minus 1 all to the power of 1 over 2 dx. Similarly, here I'm going to say minus 1 over 2 integral of x plus 1 all to the power of 1 over 2 dx. And then now I'm going to integrate now. When I integrate, I have my, I'm going to do what? I'm going to drop the half, all right? When I drop the half, it's going to be something like this. When we remember integral, when we integrate x to the power of 2, remember what is it that we do? We will be dx, sorry. We end up having x to the power of 2 plus 1 in the denominator, 2 plus 1, which is going to be x to the power of 3 all over 3. So same is true here. When we have x to the power of 1 over 2, we're going to have plus 1 all over 1 over 2 plus 1, all right, which is going to be x to the power of 3 all over 2 divided by 3 over 2. And then we know it's going to give us 2 all over 3 x to the power of 3 all over 2. So that is basically the whole idea that we are going to utilize in this particular problem. Yeah, it's very interesting. That's why I'm not looking at the camera now, because I'm enjoying what I'm doing now. So I'm having negative 1 over 2 here, and then I'm going to have the bracket. This is the first part, so it's going to give me x to the power of 1 over 2 plus 1 all over 1 over 2 plus 1, 5. And then the second part, 1 over 2, which is the one that is outside, and then the bracket, I will have x to the power of, oh, sorry, not just x, it should be x minus 1 to the power of 1 over 2 plus 1. In the denominator is going to be 1 over 2 plus 1. Similarly here, we're having x plus 1, 1 over 2 plus 1, all over 1 over 2 plus 1, and then I close my bracket. Now, remember I said it's going to get shortened up here. So now I now have the first part of the bracket is going to give me negative 1 over 2. And then here, I'll still put it inside the bracket. I'll be having x minus 1 to the power of 3 over 2. In the denominator, I have 3 over 2. And then minus, this should be like that, minus 1 over 2. In here, x plus 1, 3 over 2, all over 3 over 2. And I should close that part. Again, now let's look at the beauty of mathematics. I have minus 1 over 2. Here, it should be 2 over 3 into x minus 1 to the power of 3 over 2. I'm closing that. The same is true here. 1 over 2, 2 over 3, x plus 1, 3 over 2. I hope this is visible. If it is not, I'm gonna get angry at myself. So the 2 cancel the 2, and then I'm left with negative x minus 1 to the power of 3 all over 2 all over 3 minus 2 cancels 2 minus x plus 1 to the power of 3 all over 2 all over 3. Now, I'm going to write it in a very beautiful way. I'll end up having negative, and then I have the square root of x minus 1 cubed all over 3 minus x plus 1 square root cubed all over 3. And then lastly, I can just take out the negative 1 over 3 out and have minus 1 over 3 into the square root of x minus 1 cubed. And then I'll put a plus because I've removed the negative. And then this will be, oh, sorry. And then plus the square root of x plus 1 cubed. And this becomes my final answer. Isn't it beautiful? Or we can take it even further to say minus, in the numerator we'll be having x minus 1 cubed plus x plus 1 cubed. All this is all over 3 plus c. Beautiful. Beautiful. I thought I was going to do another problem, but this juice though.